Okay, we're in Rogowski's calculus book, Rogowski and Adams, section 4.4, problem 32. Find the critical points and apply the second derivative test, or state that it fails. So here's problem 32. F of x equals 1 over x squared minus x plus 2. First off, to use the second derivative test, we have to find the critical points. That's the derivative of a quotient, so we use the quotient rule. Let's see, low d high, well, the derivative of the top is 0, minus high d low, so minus 1 times the derivative of the bottom, 2x minus 1, over low squared. Okay, so if you were going to write that sort of distributing the negative, negative 2x plus 1 over x squared minus x plus 2 squared. Remember, critical points are where the first derivative is 0. Okay, so critical point at what is that? 1/2. Negative 2 times 1/2 is negative 1, so x equals 1/2. Or where the first derivative is undefined. So it would be undefined where the denominator is 0. So can this be 0? Well, you might try and factor it. I don't know, two numbers that multiply to positive 2 and add to negative 1. If you can't see it quickly, you might use the quadratic equation. So the solution to this would be x equals negative b, so 1 plus or minus the square root of b squared, negative 1 squared is 1, minus 4ac over 2a. Notice that this is 1 minus 4, so that is not real. There are complex solutions, but as far as zeros on the number line, this is going to be our only critical value. Okay, so we need a second derivative, but after we do that, the way we're going to apply the first derivative, the second derivative test, is we're going to just say, hey, at the point 1/2, what is the second derivative? If it's positive, we've got a local minimum. If it's negative, we've got a local maximum. And if it's 0, we don't know. The second derivative test is indeterminate. Okay, so this is again a quotient, so let's use the quotient rule. Low d high, so I've got x squared minus x plus 2 squared times the derivative of the top, which is minus 2, minus high d low, 2x plus 1. The derivative of this, I'm going to use the chain rule, so 2x squared minus x plus 2. So blank squared is 2 blank to the first times the derivative of the inside, which is 2x minus 1. Ooh, that's a little messy. All over the denominator squared, so x squared plus minus x plus 2 squared, which is to the 4th. Okay, luckily, all I need to know is the sign of that, right? So we're going to think about 1/2. I'm going to try and maybe tidy up my numerator, but my denominator doesn't really matter a whole lot because all I care about is whether it's positive or negative. And I know my denominator is positive because it's a non-zero number raised to the 4th. So let's see what happens here. I have a, let's see, a term that I could factor out, x squared minus x plus 2. That's going to be in both of these terms, right? I have one of those in both terms. So what I'm going to do is I'm going to go ahead and put the other one times the negative 2 here. So negative 2x squared plus 2x minus 4, okay? And then what else do I have here? Well, I have this times that times that. So I have a minus, let's see, 2x times 2 times 2x, that's minus 8x squared. I have minus 2x times 2 times negative 1, that's a positive 4x. I have minus 1 times 2 times 2x. That's a minus 4x. And it sure looks like I've lost a minus sign there. Oh no. Oh no, oh no. And this is the kind of work that I try to do all the time. Notice I'm thinking to myself, that's the derivative that I got, and that's the derivative. Those things shouldn't somehow cancel out, right? So when I wrote my high-D-low, I missed a negative sign. So as long as you can be checking throughout, hopefully that minimizes errors a little bit. That means this sign changes. This sign changes, right, because there's a negative with those two terms. This sign's unchanged. It didn't include that. It's negative 1 times 2 times the 2x. And then the last one, negative 1 times 2 times negative 1. Let's see, that's 2. Okay. All over the same denominator we always had. The algebra will kill us if we're not careful, so got to be careful. Let's see. So what do I have here? I have 8x squared minus 2x, so that's 6x squared. I have negative 8x plus 2x, so that's minus 6x. And then I have minus 4 plus 2, so that's minus 2. All over this thing that I'm nice and not concerned about. And my real question is, what is the second derivative at 1/2? So let's see what happens. If I plug in a half here, I get a fourth minus a half plus 2. That's positive. Doesn't matter what it is. The denominator's positive. What if I put in a half squared times 6? That's a fourth times 6 is 3/2 minus a half times, let's see, let me just make sure I'm not glossing over this. So we have a fourth times 6, which is 3/2, minus 6 times a half, which is minus 3, minus 2. That's negative. So a positive, a negative, a positive. That means the derivative is negative. That means that this is a local max. There we have it.